Right, so let's go through checkpoint 19. So we have the three identical cells, right? Each having a EMF of about 1.5 volts with an internal resistance of 2 ohm, meaning that each battery has an internal resistance of 2 ohm, are connected in series with a 4 ohm resistor, big R, first in circuit I, then in circuit part 2. So what is the ratio of the power dissipated in R in your circuit I to the circuit in part 2. Okay, the very first part, we look at the first circuit here. Okay, if you look at the first circuit, the battery is arranged in series, right? So you must add up all the EMF, meaning the total EMF is about 4.5. Same thing, you must add up all the internal resistor to be 6 ohm. Okay, so 6 ohm, then we have a big R to be 4 ohm, right? So it must help me calculate what is the total current. So using R equal to V over I. So my V is 4.5. My total resistance in the circuit is 6 ohm plus 4 ohm, meaning is 10. So you do the calculation, apparently my current, right, that's flowing through my first circuit is about 0.45 ampere. Okay, now we look at part 2, the more interesting one. Okay, part 2, you look at the first two battery or the first two cell, you notice that they are connected in this manner. So means is 0 volts here already. So the total EMF is actually only 1.5. So this is the 1.5 volts. So okay, another way you can actually do your calculation is this. So for example, let's just say if you see this battery arranged in this arrangement, right, you put 1.5 volt. If you see the battery arranged in this arrangement, you put negative 1.5 volts. So you can see 1.5 volts plus negative 1.5 volts plus 1.5 volts. So you can see that the total EMF, right, is only 1.5 volts. But the total internal resistor will still be 6 ohm. So let me write down. Okay, 1.5 volts. Right? Okay, 6 ohm, and the big R is 4 ohm. So same thing, you want to calculate the total current. So R equal to V over I. So my V, right, 1.5, my R, 10. So do the calculation is 0.15 ampere. So okay, next you simply just calculate each of the power dissipated in the big R. So because we know okay, P R is equal to I square R. So my I square in the first circuit 0.45, my big R is 4. So apparently I get about 0.81 watts. Okay, for number 2, so it's definitely much lower. So PR equal to I square R. So my I square, right, so 0.15 square, my R is 4, right? So this will give me about 0.09 watts. Then you just do a division of. For example, you use this, you divide by this, right? You'll get a ratio of 9.0 without any units. So the answer for checkpoint 19 is A.